So, hello everyone, my name is Sachin Sharma and I am from NIT Warangal, and today's topic is process. So, we will cover everything about process. So, what is process? Program under execution, okay? Program under execution is called process. Means what? There is the secondary memory called disk, and this is the main memory called RAM. If there is a program, okay, reside in a disk, means stored in a disk. If we bring this program into the main memory, okay, then this program here is called process. Okay, means what? If it bring into the main memory, then it is under the execution. So we call this same is here a process. Okay, same here. The if the a is in disk, so it is called program, and if a brings to RAM, then a is called process. Okay, so program under execution is called process. What are the functions of a process? It should reside in a main memory. It occupies the CPU, okay, to run the instruction. And third point is it should be the active and dynamic. Active means it is running the CPU, and dynamic means it takes some input and gives some output. Okay, so these are the three properties of a process. So let's see what are the various states of a process. Okay, see this. Okay, see this. So first state is a new state, then ready state, run state, wait and block state, suspend wait state or block state, and suspend ready state, and termination state. Okay, so how many state out of these state are in a main memory? So let's see. These are the state which are residing in the main memory. Okay, so these are the state which are residing in the main memory. Okay, this is a main memory, and outer this is the secondary memory. This all is a secondary memory. Outer states like new state, suspend, ready state, termination, suspend, wait state is in a secondary memory, and this is the main memory. Okay, so see what is happening here. Okay, so what is happening here? This is the secondary memory. So there are the several programs is there. Okay, that's p1, p2, p3, p4. To bringing these programs to the secondary memory from new state to ready state. So this is done by the long term scheduler, STS. Okay, long term scheduler is doing the bringing the program from the new state to ready state. So now this program is called processes. So we can say it is bringing the processes from the new state to ready state. It is done by the LTS. So indirectly it is creating the processes. Okay, it is creating the processes. So now the processes, several processes in the ready state like P1, okay, P2, P3, etc. Okay, so LTS is doing this. LTS is a long term scheduler. LTS is a long term scheduler. Okay, long term scheduler, and it is also called job scheduler. Okay, so LTS is called job scheduler or long term scheduler. Okay, so it is bringing back the new state to ready state the processes. Now, so here there is a short term scheduler is there. Short term scheduler inside the ready state. Okay, so short term scheduler is doing choose the one process which having a high priority. Choose the one process among the several process inside the ready state for the run process. Okay, to ready it is doing it is choosing the one process out of several processes in the ready state for execution. Okay, for execution is happening in the run state. So out of this, which process is going to take a CPU? Run means CPU. So you know now, one at a time only one process is running inside the CPU. Okay, so its term scheduler is choosing the process which is going to run inside the scheduler. Okay, let's say this is going to scheduler is choose the P2. Okay, now P2 is chosen, then dispatcher is take this P2 and bringing this P2 to run state. Okay, so dispatcher is bringing from ready state to run state. That are chosen process by the short term scheduler. Okay, so dispatcher is work here. Okay, so long term scheduler is bringing new state to ready state. Now there are the several processes in a ready state. So short term scheduler is choose which process is going to take a CPU, and dispatcher is bringing this process to CPU. Okay, now let's think if there are the lot of process inside the ready state. So it make a ready state more congestive. Okay, so what will happen, they are the low priority processes inside the ready state will be suspended for the some time. Okay, and they are bringing back to the secondary memory called suspend ready state. Okay, so several processes like that, they are the number of processes like P4, P5, etc. And these are the low priority. And so some of the process from ready state to suspend ready state uh, goes to from ready state to suspended state by the MTS, middle term scheduler, midterm scheduler. Okay, midterm scheduler. So to make ready state free. Okay, to make some empty space in a ready state, so it will suspend some of the process, low priority process, to the suspend ready state when the ready state is some empty or some having some spaces. So and then coming back this suspended process from ready state, suspend ready state to ready state by the midterm scheduler. So midterm scheduler is doing responsible for resuming and suspending the processes from the main memory to secondary memory, means ready state to the suspend state. Okay, so this is happening through the midterm scheduler. Okay, now when let's say when the P1 is completed its job, then it is going to termination state. Okay, then it done all the processes. If let's see the another scenario, if P1 is executing in a CPU time inside the CPU, and if it's need a IO time. Okay, input output operation, it's need a input output operations. Okay, in between, then it is going to take this output input operations. Okay, P1, now it is CPU is empty. Okay, then short term scheduler select another job like P3, and dispatcher is place this job P3 to the CPU. And when the P1 is completed its IO, then it is not going back to the run state, it's going back to the ready state. Okay, again, then again CPU short term scheduler check the priority, and dispatcher going to schedule it in a CPU. Okay, so like this circle is working, and this is the whole scenario of a non-preemptive jobs. Okay, non-preemptive jobs. So preemptive non-preemptive means if it is need a IO time, then it is going to IO, then going back to the ready state. And in non-preemptive, a process cannot going from running state to the ready state. It is not happening in a non-preemptive. If it is a preemptive, means time sharing is there, means time quantum is there. So the in a preemptive job, so process can move from run state to ready state directly. Okay, running state to ready state directly. This is done in a preemptive. Remember this. Okay, preemptive. Now let's say let's say if there are the several jobs one by one going back to the IO, okay, then this is filled up fully, okay. Then some of the process is going to suspend wait state. This is the secondary memory, and this is done through the MTS midterm scheduler. And when the and these process directly going to the ready state, okay, ready state. So this is happening. This is the state diagram of a process, okay. So there are the several terminologies like this. So first is a long term scheduler. It is bringing back these programs to ready state, okay. And it is controlling the degree of multi-programming. So degree of multi programming means how many process at a time in a RAM main memory, okay. Number of processes in a main memory at a time. So let's say they are the P1, P2, P3 in a ready state at a time. So degree of multi-programming is 3. So LTS is controlling the degree of multi-programming, okay, because it is responsible for to bringing the process in a ready state. So if we want to control the degree of multi-programming, we should do with the help of a long-term scheduler, okay. So the short-term scheduler is responsible for selecting the which job is going to take CPU, and dispatcher is bringing this selected process to CPU, okay. And MTS suspending from ready state to suspend ready state, and then bringing back to the ready state. So these are the three kinds of schedulers. So short-term scheduler also have a CPU scheduler name, okay. So short-term scheduler also called CPU scheduler, and long-term scheduler is also called long-term scheduler and job scheduler, and mid-term scheduler is a mid-term scheduler, okay. So this is the terminology. When the process is completed one by one, then it is going to termination state and goes out from the memory. So this is the various state of a process. And now see the architecture, okay, architecture of a process. So this is the important, okay. So what is the architecture of a process? Let's see. So let's change the pen. See this, okay. See this. So this is the process diagram. What are the different memory allocation in this? So let's see this. This portion of a process is a stack memory, okay, memory. And this is the heap memory, and this is the data memory, and this is the code memory, okay, code and text, okay. Now, so when the what are the functions of this? So it is stored, stack memory store the local variables, local variables and arguments, okay, function arguments, function arguments and return values, okay, return values, etc. And this heap memories is responsible for creating the memory at a runtime. Malloc, calloc functions are used, okay, and store the dynamic variables, okay, dynamic variables creating at the runtime, okay. And this data segment is storing the static data and global variables, okay, global data. And this store the code. Okay, compile code open. So let's see if this is the process architecture. Okay, and if this is the process, let's say uh, int main and global variable also there. Okay, global variable also there, like int a outside the this, and they are the static variable, static int b. Okay, and they are the several statement. Return type is a 0. Okay, and function arguments also there, function is there, and where it is taking the v and c, etc. So the static memory is storing the local variables, function arguments, and return types. Okay, and return type heap is storing the dynamic variables, and data memory is storing the static data like this and global variables. Okay, and code is other statements is stored in the code and text segment. Okay, okay, let's see when there is a heap is inside the heap, there are the several process are dynamic variables is coming one by one. Okay, so this will increase, this is the empty space. Okay, this is the empty space between the stack and heap area. Okay, if the several processes coming one by one, then this heap memory is increased to this. So this empty space is used by the heap, then this is bringing to this, and heap is increased from here to here. Okay, so this is increasing, this is called, okay, this is called out of memory. Okay, then message coming out of memory. And when the local variable function argument return type is more, then this memory segment, stack memory is using this empty space, then this is called stack overflow. Okay, stack overflow. So let's see, this is the out of memory. Out of memory message when come, when the heap memory is filled fully. Okay, and when the stack overflow is coming, when the stack memory is used this empty space fully. Okay, so to eliminate this, stack overflow, then we can do this, we can return back the parents. So they are the stack is there, they are the several stack programs is there one by one, we can return back some of the program to parents. So this stack is empty. Okay, this space is going to empty, and to remove the out of memory, we can deallocate the unnecessary memory. So this is the process architecture. Okay, so these are the four type of memory which are used by the process: stack memory to store the local variable function and this, and heap to store the dynamic variable during the runtime, data to store the static and global variable, and code for other whatever the statement are left. Okay, and what is out of memory when the heap is fully filled, and what is the stack overflow when the stack memory is use this space. Okay, fully. To eliminate this out of memory, we deallocate the unnecessary spaces, and to overcome the stack overflow, we going from back child to parent processes. Okay, so this is the architecture of a process. Now see this, so what is a PCB? Okay, what is a PCB? PCB is a process control block. Okay, process control block. So and what is in a PCB? It is store the current scenario, current status of a process. Okay, so every process having a PCB, process control block. So where the process ID is there, unique, and program control pointer is there. Process state is there, where it is in a ready state, run state, or termination state. priority is there, it is a high priority or low priority process. Registers also there, stack and block pointer is there, okay, registers. And how many open files, open file list is there, open devices, and protection information. So all thing about the process is stored in a PCB, okay, with a unique ID. So this is the PCB. Where it is stored? It is stored inside the there are the main memory. Inside this memory, operating system is there. Inside the operating system, kernel is there. Inside the kernel, there is the process table. Process table is looking like this: 1, 2, 3. These are the process PCBs of a different kind of process. This is the process table. Okay. Inside these process table, the PCB is stored. So this PCB is stored in a main memory, specifically inside the operating system, and inside that operating system kernel inside the process table is there. Inside the process table, PCB is stored. So this is all about the PCB. Okay. So this PCB stores the current status of a process. Now see this. So how the processes are created. Okay. Next topic is how the processes are created. How the processes are created by the operating system. Okay. So load the program to main memory and static data. Okay. So we store the memory program into the memory, and used for static data. Static memory data memory is used to initialize the uh, variables. Okay. So we bringing the program into the main memory and specifically static data into the data memory. Okay. And then allocate the runtime stack memory is there, and then allocate the heap memory. Okay. Then provide the task input, output, and error, and then OS hand off control to the main. So main function is there for every program. Main is there. So when how the process is created, it load the program to main memory, then distributes the variables and codes according to the memory type, either a heap memory, static memory, data memory, and distributed the task also, input, output, and error handling also. Then OS, when these things all completed, then it hand off all control to the main function. Okay. So this is how the process is created, okay, by the operating system. Now, so what is a PCB? What is a IPC? Okay, let's see. What is IPC? So IPC means inter-process communication. It is used to communication between the processes. It is a two type. So communication is happening by the two types. Okay, the first type is a shared memory, and second type is a message passing technique. Okay, so in shared memory, the two processes share the memory to communicate. Okay, and for example, process one is user mode type, and process 2 is a kernel type. Okay, then they will share the memory to communicate. Okay, let's say it's write, it read the data, and it read, write, etc. And second is a message passing technique. Okay, so in this channel pipeline is there between the process 1 and 2. Logical pipeline is there. Okay, logical. So both the processes connected by the logic, like system calls, etc. Yeah? Okay, so let's understand both type. First is a shared memory. So what is happening in the shared memory type? Okay, so both the process share the common portion of a memory to communicate. Okay, the data is written to and read in the from the shared area. Okay, so data is read and write in a shared area, and shared memory region is established by the OS. Shared memory is established by the OS. Okay, processes map their shared region into their address space, and communication is happening through the read and write operation in the shared space. Okay, so what are the advantage of this? High speed, no dependency on a operating system after the setup. When the shared memory is set up, then operating system is handle the all the things, and uh, it is not dependent. This communication, shared memory communication after the setup is not dependent on the operating system. Okay, for example, producer and consumer problem. Okay, they are sharing the common stack. Now, a disadvantage of this is the need a synchronization. Okay, so we need a synchronization technique in share memory. So share memory is also called critical section in a synchronization. You know, critical section where the common resources are take place. So second is a message passing technique. So process communication by sending and receiving the message through the operating system. So the main difference in both the technique is here the operating system is fully involved in a message passing. Okay, throughout the sharing, throughout the communication. Okay, the operating system is involved fully. The process used by use system calls to exchange the data like send and receive. A message can be fixed and variable size. Okay, advantage of this is the easy to implement, then share memory. OS ensure the message delivered and synchronized. Okay, so we need not to synchronize. So synchronization technique is not there, and disadvantage is slower than the shared memory because kernel involvement. Okay, an example is the socket programming in networking. Okay, these are the two type techniques to communicate: share memory and message passing technique. Now see this types of a process. So types of a process means there are the several processes. Okay, so see this. This is the overview of types of process. So foreground, background process is there. Run terminal user. Okay, so see this process, daemon process. Okay, system or background process without user interaction. Okay, where the user interaction is not there, the process is running inside the background. Okay, so this process is called daemon process. Zombie process is when completed but parent is watching to collect the status. Okay, means what? Means what? The parents is waiting and child is completed its job but it is not responded to the parents, and parents is watching it is complete, child is completed or not. It is called it is called zombie process. Okay, so waiting for parents to collect the status. Okay, so child finished but parents is sleeping. Okay, now orphan process is what? Parents is existed before the child adopted by the nation. So if there is a two process, parents and child. Okay, so parents create this child and parents is gone. Parent finish its job and it's gone. Now child is waiting. The child is running here and child is waiting for its parents where it's hand over its status. So parents is already gone, so it hand over its status to init. Okay, so init, so init adopt this child process in a orphan.